Hello, I'm David Longman. This is a video for EDN 205. During this video, I discuss the current state and use of information communication technologies within the secondary science classroom. Like many science teachers, I believe that we should embrace ICTs within science education. ICTs are almost ubiquitous in modern life, and proficiency in their use is no longer becoming a necessary skill, it has already become one. We use ICTs for nearly everything. Consequently, incorporating ICTs into classrooms will not only improve education, but it will also assist students in life outside of school. In addition, science education is very complex and it needs a helping hand to overcome a range of issues. These include a loss of student interest, middling academic achievement, a huge and ever-growing curriculum content, and trends away from student-centred learning experiences. Consequently, science education can benefit greatly from the use of ICTs within education. This video investigates this theme and explores 3 different information communication technologies which are used within the science classroom. These include a video named Cell Division by Paul Anderson at bosemanscience.com, a website named FarLabs, and a journal article by Kochianchik. The video Cell Division by Paul Anderson is an example of a massive ICT trend, the video lecture. These are especially popular within science education because they are content focused and consequently they address the issue of a content heavy science curriculum. This video was accessed through YouTube on the Bozeman Science channel. This video explores the basics of cell division and uses a range of ICTs to increase interest and clarity. It is similar to this video as it uses a screen capture of a PowerPoint on which the video's contents are arranged. A recording of the presenter is visible on each slide, and this routes the attention to explanations he is providing. The spoken content is supported with ICTs, including text, images, animation and video. Furthermore, by using the mouse scroller like a pointer and shuffling objects on screen, Paul utilises screen capture to direct attention. This makes the video feel more like a classroom teacher's presentation. In addition, this video links directly with many others on the Bozeman Science website and consequently encourages students to continue their learning. Video lectures have many advantages to science education. The biggest advantage is that video lectures can directly address the cumbersome science curriculum. The next biggest benefit is that videos are ideal for self-directed revision because they are rewatchable and stoppable. Furthermore, Bozeman Science offers related videos maximising revision. Video lectures are also very accessible, you just need access to the net. This video in particular utilises a range of ICTs which improve the classroom feel and teacher presence. At the same time, there are significant disadvantages to video lectures. The biggest one is that it is not student-centred. This is a particular problem for science education as exploration is essential to science understandings. Another disadvantage is that even though Paul uses many ICTs within the video, it's still just a video and a fairly one-dimensional learning experience. This journal article, titled Real or Virtual Laboratories in Science Teaching, Is This Actually a Dilemma? By Kochianchik and O'Sullivan, focuses its attention on ICT use within science laboratories. The paper describes how lab work is generally considered real when it uses physical objects or virtual when ICTs are used. The authors believe that these are not mutually exclusive, and by developing specialised ICT software, the authors utilise ICTs in real labs. In addition, they also combine hands-on laboratories with simulations to produce learning experiences which harness the advantages of both. The author's general formula for incorporating ICTs within science laboratories is shown in the experiment Superposition of sound waves. Initially, students carry out a real laboratory where they record the signal produced by 2 separate sounds. This is assisted by the use of an ICT software which visualises the recorded signal. Following this, the students use a simulation to rapidly observe signals when various sounds are superimposed, and then they are encouraged to do more real laboratory to confirm their learning in the simulation. Broken down, the following ICTs are used: specialised software which assist and speed up physical experiments, simulation or virtual labs which provide rapid exploration. Importantly, the authors point out that this method provides room for conventional teaching practices, including questioning and classroom discussion, and these are essential to good teaching. The advantages of this use of ICTs are numerous. The biggest advantage is that it is student-centered. It helps students do labs and it avoids teacher demonstration. Similarly, because it is hands-on, it caters for more diverse learners. There are numerous ICTs in this paper which work to speed up routine labs. An example is the software programs that graph and display results. This is useful as it frees up more time for thinking. There are some disadvantages to this ICT use as well. First, the software is very specialised and limited. You basically have to take what you can get. Similarly, a substantial amount of know-how is required to incorporate the ICTs into real labs, and this is probably beyond most science teachers. In addition, the paper and software is dated, it's not aesthetically pleasing, it's almost certainly superseded and may no longer be available. My final resource is a website named FarLabs. It has been developed in a collaboration between La Trobe University and the Department of Education. It is a unique resource which allows school students to perform real experiments with equipment at some of Australia's leading research centres, including the Australian synchrotron. This site is divided into 3 learning areas, but it will expand in the future to align with the Australian curriculum. Inside each section, there are several learning experiences where a variety of ICTs are utilised. One such learning experience is the turntable, which I'll run through to show you the use of ICTs. First, it uses a range of ICTs to assist in the real-time experiment. These include a live video of the experiment and site buttons, which provide simple controls. There is also a widget which graphs results in real time, and a button to export results as image files. Outside of the experiment, there are support videos which explain how to complete the experiments. There is also simulations and animations which explain the experiments in greater detail, as well as URLs and other useful web links to more information. This is an amazing website, and there are many advantages. Firstly, it is very accessible, the only requirement being an internet connection. The accessibility is enhanced by the supportive ICTs, such as the graphing widgets and videos available. Another great thing is that the experiments, such as using high-energy radiation sources, would otherwise be impossible at schools. The site also offers real experiments, not just simulations like other comparable websites, and this provides more complexity in results and greater interest. The website follows a 5E approach to science education and consequently provides complete learning experiences. In addition, the large content and URL links provide significant extensions. Though FarLabs is amazing, there are some limitations. The major one being that though the experiments are real, the website control over the parameters is pretty limited, and it thus loses the complexity of a real experiment. The site is aimed as a bridge between secondary and tertiary education, and consequently, the learning experiences sometimes are too complex for most year levels. This video has explored 3 ICTs used in science: video lectures, ICT-assisted physical experiments, and virtual laboratories. However, there are many ICTs within each of these resources. These have included video and animation studios, and word processing and presentation softwares. It also includes specialised laboratory softwares. Furthermore, they also utilised web features such as search engines like YouTube and website buttons. There are both advantages and disadvantages to ICT use in teaching. To me, the biggest advantages are accessibility, not just because ICTs are very accessible, but because they give access to resources which are otherwise unreachable. They also greatly increase the speed of learning. They can be very student-focused and provide student-centered learning experiences as well. In my opinion, the most significant disadvantages include a risk of defocusing students, especially if the students are not actually using the ICTs. Often ICTs are specialised and need specific skills to use them. This can reduce accessibility. Lastly, ICTs can become dated and superseded very quickly. There are a multitude of ICT resources out there. Science teachers should take time to explore the resources available, discover their assets in relation to learning, and decide which ones suit their needs. Following this, they should carefully develop learning experiences which harness the advantages of these ICTs. They should focus on building student-centered experiences where students actually use the ICTs, as this will utilise student enthusiasm for the technologies, while simultaneously improving ICT literacy. During science practicals, teachers should utilise ICTs to increase the speed of routine tasks so that students can spend more time in deeper thinking.